Hello and welcome back. We are going to be determining the electron and molecular geometry for each of the central atoms in acetic acid. We're also going to determine the approximate bond angles in this molecule, and especially taking note of the presence of lone pairs and how they affect the bond angle. So let's go ahead and start off with identifying the electron and molecular geometry. We're going to first start off with this carbon, and I denoted it by the asterisk just to make things a little bit easier and to make sure that you know which one we're following throughout. So this carbon right here has 4 electron groups, 1, 2, 3, 4. Remember, electron groups are any bonded atoms, either single, double, or triple bond, and lone pairs. Out of these 4 electron groups, how many of them are bonding? Well, each of these are single bonds, so we have a total of 4. We do not have the presence of lone pairs around that carbon. And so in this case, my electron geometry and molecular geometry will be the same. Remember, molecular geometry takes into account the presence of lone pairs when we determine the molecular geometry. In this case, we don't have any lone pairs, so the electron geometry and the molecular geometry will both be a tetrahedral. I'll denote that as TH. Let's go ahead and work on this central atom. So this carbon is going to have, we're going to determine how many electron groups it has. It has 1, 2, 3. Of these 3 electron groups, how many of them are bonding? 3 of them are, and we have no lone pairs. So this is going to be a trigonal, planar, I'm just going to put a tri-P for the shorthand, and they're both actually going to be trigonal planar geometries. Remember, trigonal, when you're dealing with the molecular geometry, a molecular geometry and electron geometry only differ between the two if you have the presence of lone pairs. Finally, let's go ahead and do the oxygen. This oxygen has a total of 4 electron groups, so 1, 2, 3, 4. Out of those 4 groups, 2 of those groups are bonding and 2 are lone pairs. Okay, so at this point, we know my electron geometry and molecular geometry are actually going to be different from one another. My electron geometry is going to take in consideration all my electron groups, so this will be a tetrahedral. However, my molecular geometry will take into consideration the repulsion that lone pairs contribute to the geometry, so this is going to be a bent geometry. Let's go ahead and look at the different bond angles associated between these. The groups attached to this carbon are going to be roughly 109.5 degrees from one another. In the case of trigonal planar, they're roughly 120 degrees. And in the case of bent, we know it's going to be less than 109.5 degrees. So that's going to be less than 109.5. Please remember to always take in consideration when you are dealing with electron geometry and molecular geometry, to always take into consideration the presence of lone pairs, because they are going to affect not only the geometry but also the angle between each of the bonded atoms. Thank you.